Hello everyone, my name is Naftali Ida. I manage the application engineering team for the PolyJet technology, and today we're going to go on a whirlwind journey of color and some recent improvements to our PolyJet capabilities, and we've made a small change that yields some amazing results. So let's get started. First off, we're going to do a quick color basics and terminology review so everyone can understand the topics we're going to talk about later on. So first off, we're going to talk about LAB. That's the color space that the human eye can see, and it contains approximately 1 million colors. Next, we've got a term called delta E, and that is a way to measure the difference between colors. So delta E is a single number, represents the distance between two colors. So if you've got two colors next to each other, you can just about tell the difference between them. That's 1 delta E, and it's based on a mathematical formula. So a color gamut is the entire range of colors available on a singular device or color space like a monitor or printer, and an ICC profile is a set of standardized data that describes the properties of a particular color space. So every device has its own ICC profile if it can process color. Finally, RGB and CMYK. So RGB is what is used on a computer, screen or monitor, and CMYK is the output typically from a printer. So RGB is based off light. So in order to render an image, you have 3 different colored pixels, red, green, and blue, versus CMYK, which is a subtractive process where the different colored inks subtract from the white of typically a substrate piece of paper underneath in the 2D world, and here the different drops of pigment are positioned relative to each other, next to each other, overlaying each other in different proportions to obtain the colors that you want. So let's move on to talk specifically about RGB and Adobe RGB, and that's really the main topic of today's session. So imagine the early days of the internet back in the 90s. Remember those big bulky CRT monitors? Well, displaying colors accurately across screens was a real headache. Every monitor seemed to have its own idea of what red or blue should look like. It was a confusing mess. That's where sRGB comes in. In 1996, HP and Microsoft said enough is enough. They created sRGB, a kind of universal language for color. It wasn't perfect, but it ensured a baseline standard for how colors would be displayed on most monitors. It was a game changer for the internet, making sure that, those funny cat pictures looked the same everywhere. But the story doesn't end there. Photographers, especially professional photographers, had a different problem. They were capturing all these beautiful, vibrant colors with their fancy cameras, but when they tried to print those photos, the colors looked dull and lifeless. Why? Because printers use a different system, CMYK, that we just spoke about, cyan, magenta, yellow, and black, and that has a wider range of colors than most monitors of the day could display. So that's where Adobe RGB burst onto the scene in 1998, and that came from the boffins at Adobe, and this new color space aimed to bridge the gap between what cameras captured and what printers could produce. It offered a wider range of colors, particularly those lush green and blues that often got lost in translation. Now photographers could capture those stunning nature shots and see them come to life on high quality prints. So now in this image, we've got the sort of colorful circle shape representing that LAB color space. That's all the colors that the human eye can see. And within that space, we can see how the range of CMYK colors marked with a black line extends beyond the bounds of the sRGB shape. This means that when defining colors in sRGB, there are colors that you can technically print on your device, but have no way to access them. However, if we now add Adobe RGB, a color space that expands the printable range of colors significantly, here we can see the Adobe RGB form representation encompassing a larger spectrum of colors, expanding towards the more vibrant edges. This allows it to capture those captivating green and blues that the sRGB might miss. So imagine the emerald depths of a rainforest or the breathtaking turquoise of an exotic lagoon. Now, we understand probably more than you ever wanted to know about Adobe RGB, and let's take a look at how to implement this in GrabCAD Print. Well, it couldn't be simpler. Here we have a model imported into GrabCAD Print, and we're simply going to navigate to the tray settings, and from there we'll select the advanced tools, and from the input color profile drop-down, we'll change it from the default sRGB to Adobe RGB. And that's it. We're ready to send the part to print. And let's look at some printed models so you can see what the difference is going to be. Here we can see on each row of these parts a different single color applied using the color picker within GrabCAD Print. The left is sRGB and the right is Adobe RGB. And in the table you can see the actual colors that we've selected. So you can see that these colors are highly saturated. They're above sort of 200 in the RGB space, and we can see a real change in the output of the color. So another example here, we've got a photograph of the image that we used earlier. Both of these are printed on the left in sRGB, on the right in Adobe RGB. And here I've highlighted some of the areas to look at for some noticeable differences in color. We've got some improvements in reds. We've got some beautiful sky blues. We've got these healthy lush greens. We've got this rich sea blues, and we've got some intense forest greens as well. And here's a dynamic comparison between the two as well, and we can really see that difference in vibrance and vividness across the image in Adobe RGB compared to sRGB. So, in our final printed example, I wanted to highlight another area where we can see an improvement when using Adobe RGB, and that is when printing skin tone colors. In this case, we purchased a head scan from the 3D scan store, and here you can see on the left the on-screen render reference and the sRGB print. Unfortunately, this printed model with the sRGB, it lacks life and seems a bit pale. However, when printed in Adobe RGB input profile, we can see there's more warmth and realism in the skin tone colors. So let's summarize. If we take a look at some of the numbers, the Adobe RGB gamut is over 45% larger than the sRGB. And if you use the Adobe RGB input profile, you can access an additional approximately 100,000 delta E colors compared to using the RGB workflow. So when the user specifies an RGB color, they're making a reference to a color as seen on some display device. The user must then tell GrabCAD Print something about that display device. Was it an old TV set of the 50s, or was it a modern OLED monitor? Having failed to do so, GrabCAD Print until today assumed that the color seen was dull and so printed a dull color. Now, by telling GrabCAD Print that the color was seen on a good monitor, Stratasys will try and print a more vivid color to better emulate that selection. To review and some closing remarks. So it's a color gamut, Adobe RGB, that can capture a wider range of colors and those are more similar to those used in professional printing rather than, say, those that you can represent on a monitor. The target is really for customers who are interested in more saturated colors. So that could be, say, figurines and collectibles or entertainment markets, and that would be, say, packaging as well. It's available and it's easy to apply. It's available for anyone that uses GrabCAD Print. You don't need Pro. Now, call to action is go off and print some of these models. I've got a sample tray you can access from the QR code here, and print it once using the sRGB profile and then a second time using the Adobe RGB, and you see the difference for yourself. Thank you very much for your time today, and happy printing.